Okay, so we've already looked at rectangular prisms and triangular prisms and how to find the volume. So when we were finding volume, we were looking at how much space was inside the three-dimensional figure, and we measured that in cubic units. Well, there's one other thing that we can do with three-dimensional figures, and that is find their surface area. I think the best way to think of surface area is think of wrapping paper. So you're going to wrap the outside, and that would be surface area. You're covering every face. So within surface area, we have two different things that we look at. When we talk about surface area, we're talking about the sum of the areas of the faces. So we find the area of each face. So in the case of that rectangular prism, we're finding the area of the top and bottom, the front and back, the two sides, and we're adding all those together, and that would be surface area. And then we can also talk about lateral surface area, and that's the sum of the areas of all the lateral faces. In other words, the faces that go around, sort of in between the two bases. So lateral surface area does not include the bases. Okay, so if we look at this rectangular prism here, if we wanted lateral surface area, then we wouldn't do this top and bottom piece. We would just be talking about the two sides and then the front and the back, so kind of around the figure, and that would be lateral surface area. So if we look at this, rectangular prism, if we want to find the surface area and the lateral surface area, then let's break it down into its faces. So we have a top and bottom. They look like this. This is the top and the bottom. Okay, and they're the same. So the top and the bottom are both 8 by 5. And then we have two sides. Try that again. So then we have two sides that are 5 by 3. And we also have a front and back that are both 8 by 3. Okay, so we can look at it that way, and then just remember that you have two of each of those. So as far as the top and bottom go, those are 5 by 8s, but there are two of those. So if you look right here, here's top and bottom. So 5 times 8 is 40, 2 times 40 is 80. So for the top and bottom, we have 80, and that would be square meters. But it's talking about area. Okay, we're not doing volume, we're looking at area of all the faces. Then we can move back to the two sides. And the sides are both 5 by 3. So 5 times 3 is 15, but there's two of those. So 2 times 15 is 30. So that gives us 30 square meters. And then if I look at the front and back are both 3 by 8, but there's two of those. 3 times 8 is 24, and 24 times 2 is 48. And that would be square meters. So in order to determine the surface area, we're going to add the areas to determine the surface area. So the surface area is going to be 48 square meters plus 80 square meters plus 30 square meters. So if we add all that together, 48 plus 80 plus 30, we get 158. So the surface area is 158 square meters. Okay, so in other words, if you were going to wrap that rectangular prism, it would take 158 square meters of whatever it is that you're going to wrap it with. Now, if we're talking about lateral surface area, so just the lateral faces, then we're talking about the front and back, and then the two sides. Okay, so we're talking about this side, and we're talking about the front and the back. So everything except the top and the bottom. So we already found out that the front and back are 8 by 3, and there's two of those. 8 times 3 is 24, times 2 is 48. So that's 48 square meters. And then the two sides are both 5 by 3, but there's 2 of those. 5 times 3 is 15. Double that and you get 30. And so we just add that together, 48 plus 30, and that's 78 square meters. So if you're talking about lateral surface area of that rectangular prism, then you get 78 square meters. And so just pay attention when you're looking at surface area. Make sure you know whether or not you're being asked for lateral area or total surface area. Okay, so let's look at this one. So let's go ahead and find lateral first, and then we can just add the top and the bottom in there. So for lateral surface area, so we're talking about the front and the back and then the two sides. So the front and the back, and those are 2 by 2, but there are 2 of those. Well, 2 times 2 is 4. Double that and you get 8. And then we're also looking at the two sides. Okay, so basically everything except the top and the bottom. So the two sides are also 2 by 2, but there are 2 of those. And again, 2 times 2 is 4, and if you double that, you get 8. So our lateral surface area, 8 plus 8 is 16 square meters. Now to get total surface area, we also need to include the top and the bottom. So our top and bottom, in this case, are also 2 by 2. So what we're looking at here is a cube, but there are 2 of those, a top and a bottom. So again, we get 8 square meters. And we can actually just add that to the lateral surface area, because that was the two sides in the front and the back. So we could say the lateral surface area is 16 square meters, plus the top and bottom is another 8 square meters, and 16 plus 8 is 24. So our total surface area is 24 square meters, and our lateral surface area is 16 square meters. Let's do this next one, and again, let's go ahead and start out with lateral surface area. So we're going to look at the front and the back. And the front and back are both 5 by 2, but there are 2 of those. 5 times 2 is 10, double that and you get 20. So that's 20 square centimeters. And then we can look also at the two sides. Those are both 1 by 2, but there are 2 of those. 1 times 2 is 2, double that and you get 4. So the two sides are a total of 4 square centimeters. So if we add that, so 20 square centimeters plus 4 square centimeters, then we get 24 square centimeters, and that would be the lateral surface area. Okay, so on this one, if we want to talk about total surface area, then that means we want to include the top and the bottom, which are both 5 by 1s, but there are 2 of those. Well, 5 times 1 is 5, and if we double that, we get 10. And now we want to add that 10 to the 24 square centimeters from the lateral surface area, and we get 34 square centimeters, and that would be our lateral surface area. Excuse me, our total surface area, our total. Our lateral was 24 square centimeters, and our total would be 34 square centimeters. Let's get one more. Okay, again, so let's start with lateral. So for lateral surface area, we're looking at the front and the back and the two sides. So front and back. And there are 2 of those. They are 10 by 5. So we have 2 10 by 5s. Well, 10 times 5 is 50. Double that and you get 100. So that takes care of the front and the back. Then we also need the two sides. And those are 2 by 5. So 2 2 by 5s. And 2 by 5 is 10. Double that and you get 20. So the two sides have a total of 20 square feet. So when we add 100 plus 20, we get 120 square feet. and that would be, again, our lateral surface area, okay, because that includes everything except the two bases, the top and the bottom. Okay, so now let's get our total surface area. So now let's look at the top and the bottom. And those are both 10 by 2, but there are two of those, so two 10 by 2s. Well, 10 times 2 is 20, double that and you get 40. Then we can add that 40 to the 120 we got with our lateral surface area. So our total surface area is 160 square feet. Okay, so easy as that. Lateral surface area, just think that's kind of wrapping around, almost like you were going to put a label around it. And then total surface area, we'll go ahead and add in the top and the bottom. Okay, now let's look at the same concept but with triangular prisms. So the surface area of a triangular prism, so we're talking about total surface area here, is the sum of the areas of the two triangular bases and the three rectangular faces, so all of it. And then again, lateral surface area is just the areas of the triangular, the lateral surface area of the triangular prism is just the sum of its lateral faces. So lateral surface area does not include bases. Okay, so it's going to be just the rectangular lateral faces. So if we look at this first example, if we want to look at lateral surface area, so lateral is going to be everything except the bases. So in other words, we're talking about that rectangle and that rectangle and that rectangle. Okay, so let's look at that first one. The first one that I have in purple is a 20 by 12. So again, we're finding lateral here. But you can see there's two of those. So you see the one that I have in purple and the one that I have in orange. They're both 20 by 12. Okay, so the area of that 20 by 12 rectangle is 240 square centimeters. And then we have another 12 by 20. So that'll be another 240 square centimeters. And then we have the orange one, which is another 20 by 12. So that gives us another 240 square centimeters. So essentially, we're really just tripling 240. So our total lateral surface area is 720 square centimeters. That would be our lateral surface area, so everything except the bases. And then if we wanted total surface area, we would of course have to go back in and find the area of these two base triangles and add that to our 720. Make sure I didn't skip one. Okay, so in example 2, now we're looking at the surface area. So this is talking about total surface area. Okay, this one is not in its net form. It's much easier when it's unfolded. This is called a net. So it's much easier when we see it in its net form because now what we have to be able to do is kind of break this down into its individual faces. So I know that we have this base triangle that looks like this, and there are two of those, and it has a base of 12 and a height of 5. Now let's look at the rectangles. So let's look at this rectangle right here. So the one that's on top, the one that would kind of form the ramp piece. And we can see that it is a 10 by 13. Let's go ahead and label these. I know I have two of these. I have one of those. Okay, now let's look at this back rectangle back here. Okay, so I've got a rectangle that looks like this. and it appears